My name is Xavier Rafai. I'm going to talk about my experience in implementation of critical chain using realizations tool Concerto in the automotive product development environment. It's exciting and great experience, and I'm going to share that with you. The implementation focus was right here is a simple depiction of overall process map of where idea comes to fruition, and our focus was between these phases in the prototype build area, where we get these fancy concepts that are transformed into actual cars on wheels, where we build a whole bunch of prototypes. And prototypes is our livelihood. A lot of money actually goes into this this phase of product development. Just to give you a financial perspective, our product development cost is in the neighborhood of $1 billion in a calendar year, and out of that 60% is spent on prototype development. It gives you an idea. And we have in this implementation, we just focused on the build area where we build the prototypes, and there are three key areas or organizations. Body in white, where we put these the basic metal work, where we weld doors and body and floor pan together, and that flows to paint. And then at the end, we put the powertrain and interior trim and electrical wires, and the vehicle is ready to be tested. And the main focus in the prototype phase is to find out how did your design do when it comes to an actual transformation. And then we have certain program objectives that have to be verified through either testing or trial of manufacturing process. So that gives you an overall view of our implementation focus area. It was again in the prototype build and only in the build area, and those are some of the key steps. So anyways, we formed an organization called Vehicle Planning Group. That's where the implementation of Concerto began. And during the implementation, working with realization, we were able to develop 4 major work streams. And first work stream was to capture all the information or data regarding these prototype builds of the future calendar year, look at it, and then model them. That means generating critical chain models, doing the pipeline, and trying to level load. And then execute those plans throughout the calendar year. So this execution would be of the previous planning. And the work stream number 3 is improving some of the processes from the lessons learned from previous execution of projects. And the peaks and valley I'm showing here is an actual load that we looked at for 2004 in 2003, and which we level loaded to fit with the capacity that we had. So walking in, we had a very good idea of what our loads are going to be, and in certain areas, if the loads were high that we could not really fit within our capacity, we were able to plan for some overtime, because overtime is a big issue for us. Sometimes it's considered as an exception management, but in our area, it's a planned increase in your take-home pay. It compensates people, and if you know what I'm talking about. And I'm just going to show a detailed breakup of our work stream number 2. So let me just flip back here, and that's work stream number 2, where we collect data, analyze, do pipeline, and this is the detail of it. What we do is we do modeling of different templates, which again, with help of realization, we were able to capture very close to reality in terms of the different project models we have, and we had a whole bag full of different templates that we could just pull out and put the information against it. And all those models are created, they're stored into the Concerto database. Then we look at our capacity and the demand, and then we do pipeline planning wherever possible. If we can scrub the peaks, we try to do that. And then we also do an analysis, because as you all have heard about outsourcing, right? That's the new buzzword nowadays. And we also do some outsourcing, because if our capacities are full, we have to strategically go out. And in this case, we do, because of the information generated out of the tool, the pipeline planning portion of the tool, we are able to make a conscious decision on what projects to send out. And sometimes the criteria is sensitivity of the program, newness in the program. If we don't want our competition to get an idea of what we're working on, we contain those within our boundaries, and we send the other work outside, like the carryover projects where they're just minor changes. So that was kind of background of what we do, how where we implemented the solution. Now, some of the benefits on the soft side. People walked around with their own local prioritization concepts. I'll give you an example. The resource manager in Body and White organization had spent 30 years in his area, expert knowledge. And in our prototypes, we have partial properties and we have full properties. That means we have full prototype built, complete car on wheels that can run. And sometimes we build partial properties. That means we would just build maybe the front end of the car, which cannot roll. It needs to sit on a bench. And this Body and White resource manager had figured out, based on his experience, that partial properties are not as important as full properties. Completely based on his experience, because he had to work less on partial properties. But turns out, in overall product development, partial properties are very important for HVAC or air conditioning and the AC lab people, where they develop their duct work and balancing of the airflow and all that stuff. They really need these partial properties. So from his local realm, he thought that partial properties were not important, and that's how he prioritized his work. He'll do all the full properties first, and then work on the partial properties. And again, delivery of these prototypes are very important, because that commences the testing phase of a product development life cycle. And then the paint organization, this guy, he prioritized based on who came and pounded their fist the loudest, hardest. That's how he prioritized his work. And the person in trim chassis organization, his prioritization scheme was very unique. Whoever brought donuts and coffee, they got the work done. So we, by using Concerto's buffer index concept, it has really taken that subjectivity out of it. It's no longer an individual's way of prioritization based on their experience or how they've seen the work in the past, and it has really helped us create common prioritization. That was one of the like a subjective kind of benefit we derived. Very important for us. And the other thing was delivery date performance. So let me explain a little bit about this thing. Every prototype project that we build has a planned delivery date. And we live with some type of lateness, and we can handle some early, because we cannot, if a plan for building a prototype was some date, and if it was delivered 3 weeks early, then there's a problem. We don't want that to happen. So one of the boundaries for us is, you can't see it well here, but let me just tell you what these lines are. This is 7 days early, this is 14 days late. So we can handle something which is 1 week early or 2 weeks late. And before the implementation, and I'm calculating the process capability number. If it is 1, that means all my samples are within those boundaries. And as the lower the number, that means you have things that are seeping out of those limits. So as we went along, 2nd month, 3rd month, 4th month, and in 5th month of implementation, our samples were within that range. And we improved from 0.41 to 0.72. It's like, if you are at the target practice, right? You pull down your target, it's sprayed all over the place. Instead, now we're zooming into specific area. So that was one of the huge benefit, about 76% improvement in our process capability of hitting the delivery date. And delivery date is very sacred for us, again, because of the fact that time to market is very important for us. I'm going to show you some slides to articulate why speed to market is important. But we cannot miss some dates. These are like certain gates and certain events, or the testing of the prototypes is very important. And obviously our launch dates in the production plants are also etched in concrete. So that was the second piece of the importance. And the other thing is, over a period of time, Concerto's capability of storing the information on tasks can also help you in continuous improvement. Gentleman from Bosch was talking about the continuous improvement. In my mind, any initiative, any project follows three distinct phases. You have planning or strategy, you have implementation or execution, and then you have continuous improvement or sustainment. And this is really the help that you derive from a tool like Concerto in the area of continuous improvement. Here, what we did is, typically these are our timing templates. Our timing template that we allocate in our overall product life cycle is 10 weeks given to a prototype, which goes through body and white, paint to trim, chassis, final. And having used this tool from 2003 to 2004, we were able to capture the typical duration of these tasks. And here's a classic log normal distribution. And here's the average duration for body and white. This is average duration for paint. This is average duration for trim, chassis, final. And if we take these average durations and plug in our 50% buffer, you have 99.99% statistical guarantee of finishing it. But see what we have been able to cause. 8 weeks from 10 weeks. This is the benefit and sustainment portion of using this tool. Just a show of hands, everybody's probably read The Goal, right? Or most of you? Yeah. So talking about the constraint concept, a simple explanation is your system, your organization, or your company is as strong as your weakest link. And identifying that weakest link and leveraging the weakest link is the basic essence of increasing your throughput. And now putting this into project perspective, from the automotive side, I mean, every project we launch, let's say Pacifica, Crossfire, Durango, some of the cars, product lines I'm talking about, when they hit the market, that's when we realize our revenues, right? And that is called the slope of revenue generation. Back to the theory of constraints, the goal book. Let's say if you have three processes, one of them is your constraint. What you do is you see work in process inventory, and then you have a loss capacity in the downstream processes. And if you can cause the capacity at your constraint to go up, you can significantly improve your throughput. And every time you increase the capacity at your constraint, you get more and more throughput benefits, right? So taking the same analogy into a project environment, if you can cause, now you have to have a hunch where your constraint is in an overall project. It's like hitting the oil, right? You don't want to dig up the whole place. You just have a hunch, you do some analysis, you got some idea, then you drill. Yeah, if you hit the oil, you're lucky, right? And you may not be at the first time. The same concept here, some of our experts in product development nudged us in the path of identifying where the constraint could be. So we deployed the solution in the constraint area, and every improvement we do, now we haven't done these step 1, 2, and 3. We haven't gone there. This is where we are heading towards, because the tool has shown us this opportunity where to go reduce cycle time. If we do that, our slope of revenue generation changes, and that's where the big bucks are. So here's the depiction. If you spend some money in reducing that cycle time at the constraint, you keep doing it, your revenues keep going up.